Morning, or should I say good morning to some of you who are out in the APAC region. Good afternoon, good evening to some of you who are in the time zone that we are all in. Welcome to the MLflow Meetup, community meetup. My name is 𝗕𝗲𝗲𝗍𝗔. I am part of the technical staff here in the developer relations team. And joining me is Carly, who is actually in the background doing all her magic to come live on X, MLflow X, and LinkedIn and YouTube. So wherever you are joining us, please drop in a line and say hello. And joining me is my esteemed colleague and my old friend, Ben Wilson, old friend of mine who has been working on MLflow for the longest time that I know, is familiar with the community as well. Is also the author of the MLflow Machine Learning in Action. So if you haven't read that book, you should probably check it out. And is a maintainer and a contributor of MLflow for a long time. Ben, you want to say hello to everyone?
Hey, everybody. Nice to see
Thank
everybody again.
Thank you. Thank you. Yeah. So let's get started, I think, before we actually have a good hour to talk about MLflow today. Just a couple of things I just want to mention before we hand it over to Ben. Today's agenda is quite simple. I'm just going to go through a couple of slides. Have you, as part of the MLflow user, or if you're new to the MLflow user and you want to get used to it, how to participate in the MLflow community. Our community is expanding on a daily basis, and we have various channels which you can actually use. And today's agenda is quite simple. We have two sort of themes and topics that Ben is going to focus on. One is managed data sets. What does it actually mean to have data sets that change as your application changes, and how you can actually use that in evaluation? And agentic judges, how you can actually use MLflow for agentic judges. So I think that's going to be an interesting topic of discussion today from Ben. And let's see how you can participate in the community. Well, we have several means you can do that. One way is to join our Slack channel, which is quite active 24/7. So a lot of people are asking good questions, both users, developers, commuters. Good way to get engaged with some of the users to share how you're actually using MLflow. If you're one of the contributors and you want to contribute, you can actually go to the GitHub MLflow and start looking for first issues or easy issues. We always look for contributors to help us in everything: documentation, code examples, API documentation, usage, and all those. So feel free to browse at the GitHub and have a good look at some of the first issues that we are interested for people to start contributing. You can also subscribe to the Luma MLflow page, so that way you don't miss any of the events that actually come up. There is also an MLflow LinkedIn page. You can actually do that and follow us on Twitter and our website as well. One last announcement. One of our contributors and commits, Danny Chow, is speaking at the MLOps conference tomorrow in Austin. And soon after that, as soon as this talk is over, this is the first time we're trying this out, we're going to have a live AMA. So come and join the contributors and committers from the team. October the 9th, tomorrow at 1 p.m. Central Time. This is going to be on the MLflow general channel. The team will be here, and you can ask any questions you want. And this is going to be text based, so you're going to be you won't hear any audio, but we'll be there to answer any questions. So scan the QR code over here, and hope to join us tomorrow. With that, Ben, it's all yours. Just tell us all about the MLflow 3.0 coming up, 3.5, and all evaluation experience. Enlighten us. I'm looking forward to hear that.
Yeah, sure. I think I'm sharing now. There we go. Maybe. Let me test. Okay. Yeah. So MLflow 3.5. We're about to release, tentatively, I think it's tomorrow, might be tonight sometime, the release candidate for MLflow 3.5. And I'll be talking about things that are in that, but as well, also things that we released in 3.4 as sort of a prelude, and sort of foundation layer of things to really focus on the GenAI evaluation experience. If anybody has been working on GenAI using MLflow for, the last 2 years or so, that we've been focusing on bringing over features to make the GenAI development experience a little bit easier, and to enable the features that MLflow has at its core to sort of apply to GenAI workloads. over the last few releases and over the next few, we're going to be focusing on listening to the community and what people have told us about things that are processes that aren't as streamlined as they possibly could, in order to make two aspects. Right now, like today, we're going to talk about what we call the dev inner loop. And that's the process of developing the application, running through evaluation tests internally. So you have a bunch of things that you want to vet. You have some subject matter experts that you're working with who can basically provide feedback on the results to say, is this actually good? How do I make it better? And that iterative development loop before you're ready to actually push something out to production. In coming releases, we're going to be focusing on the outer loop as well, which is the after I deploy this thing and I start collecting more data, how do I streamline that experience to iteratively improve things and make sure that things aren't drifting, or that you can detect when things are going to go wrong. But before I get into any of the nitty gritty details, here's the two sort of, thought ideas that we had when focusing on the last, the upcoming release and the previous release, which is the eval process for traditional ML is hard enough. It requires collecting a whole bunch of, valid data sets, building a model, training it, tuning it, and then running through validation, making sure that you're interpreting your results correctly, and kind of re-architecting through feature engineering work and maybe different model selection to get a more optimal, problem statement that you're solving. Whatever that project may be designed to do, you're trying to optimize that. However, in the Gen AI world, it's way harder to do this. Not only are we dealing with non-deterministic systems with respect to LLMs, but we also have, with more complex systems like agents, you can now build things that are incredibly challenging to evaluate. You can do things like unit tester tools, which you should be doing anyway, but there's another barrier that's in there about when you're interfacing with a given LLM and all of the major providers as well as open source models that support it. They can choose to use tools at different times, and they can perhaps make reasoning chains that aren't exactly what is ideal. So being able to evaluate that in a standard way where you're not having to write loads and loads of code in order to just evaluate something, or going through the process of evaluating it and then having to tweak your evaluation, your judges that you're using. Sometimes that whole process, what we found, and by talking to people and testing it out ourselves, is that sometimes that's actually more work than building the agent itself. So some of the things that we, have looked at is everything from the creation of your test data, what you're actually using to validate your agent is very time consuming. It's somewhat easy to do smoke tests. You're just asking it general questions that you think, users might be using, or, questions that are within that specific domain, but it's not, quite as easy as it is collecting data for traditional ML. You can use production data and clean it up and sanitize it and then use that as your test data. For Gen AI, it's a little bit more complicated. And then making sure that your data is up to date, that you can do not only tombstoning of collections of data, but also that constant addition of data to a data set without having to, replicate data and create n number of versions of different validation sets. We heard a lot about that, about like how incredibly challenging that is. And another point is going through manual evaluation, doing dog fooding. After you build your application, you just give it to a bunch of people to test. It's highly skewed. There's not always great participation. You might not be able to get the people who really know what the output should be from a different test, regimen to actually participate in something like that. So that doesn't really scale, doesn't really work that well. And then when you're defining what your evaluation functions need to be, that whole process of, writing instructions for an LLM to interpret what the input, output, and expectations are, you're basically going to this prompt optimization cycle. and doing prompt engineering ad nauseum in order to get something that kind of works fairly well for what you're trying to target. And the process of aligning that to how a human would evaluate it, like a subject matter expert would evaluate the quality of the evaluation that's being done, is very painful right now. And then, what you get from an assessment from an LLM, there's a trade-off between the quality of the LLM and how much it can infer from the instruction set that you give it to how much does it cost. So if you want the best results right now and you just want to do standard prompt templating to create an evaluation, you're going to be using the latest like Opus model from Anthropic or GPT-5 like base model from OpenAI. Very expensive to do when you're talking about the volume of data. And that whole process, basically, we've heard enough from people about how painful it was. So we wanted to spend quite a bit of time and our resources on making this as simple as possible. So our first iteration is, basically this in code. Gone is the need to write a very big, complex prompt template or to rely on built-in evaluators that you would then have to write a bunch of boilerplate code to kind of package everything up to make it usable. And what you see on screen is usable in and of itself, just as is. And this would actually evaluate an agent. And we'll see later on in the slides, like this actually working, and what the results in the UI look like. But basically the first part of what we're going to talk about is the data set aspect. And data sets are a durable form of data storage. And in MLflow, that means this data is actually stored in the tracking server and it's indexed. So we can create a data set and we can reuse that data set. A little bit of a departure from other MLflow APIs. We wanted to make it a little bit simpler. Instead of having distinct Fluent APIs where you're like, okay, create data set and then MLflow.add rows or MLflow.delete rows, we just created one interface for it. So in that first code block that you see, we have that create data set, we're giving it a name, and that's something that's referenceable. You can search by that. And we're assigning it to an experiment. And that's really important for lineage tracking and for basically knowing where your results are going to be written to when this thing actually runs. And then when you want to add records to it, you just use this merge records command, and that's on the actual object itself. So the actual evaluation data set has a method called merge records, and you can input dictionary collections, so like inputs, outputs, expectations. You can put in a pandas data frame, and it'll just parse it and put it in to the tracking database. Or the most powerful one is you can just put in a list of traces. So trace objects that you have, something that you might have done in testing, and we basically parse all of the parts of that in order to conform that into a data set record. And then you can then use that data set. You can use, there's a number of APIs, like CRUD APIs that you can use, but the most useful one is like search data set, so you can get the data set. And once it's a lazy loaded function, so the object will return with just its metadata. And then once you try to access rows in it, then it'll do the fetch and actually get all of those records in to memory. And once you have that data set loaded, you can use it to evaluate against multiple different agents if you wanted to, or you want to test a bunch of different things out. You can now have this sort of standard data set that has that structure that you really want. Of, hey, I have a bunch of inputs, I have some expectations, or I have inputs and I have outputs, or I have inputs, outputs, and expectations. These combinations are all compatible with different scorers, and we'll get in a couple minutes. And those scorers will actually, read that and put it into a template that an LLM can then judge with sort of a system prompt instructing it what to look for and how to deal with that data. So that's the merge. That's like the whole data set aspect of it. What's coming in MLflow 3.5 is, so this was released in 3.4, the API is the backend. What's coming in 3.5 is an actual UI front end. So you can actually see these data sets and interact with them within the MLflow UI. It's going to be like a new page that'll be associated with experiments. And once we have that all set, we can then move into a much more streamlined new thing that we just released. First iteration was in MLflow 3.4. We're making a bunch of changes to it, improvements, a couple of bug fixes in MLflow 3.5. And you can see on screen here what that API actually looks like. So instead of what you may have seen in MLflow when you're creating an evaluator, historically, there was a lot of code that you had to write, a lot of, imports that you had to do. You had to basically construct this through like basically a builder pattern, like up this evaluator object. And then you could use that in MLflow.𝗕𝗂𝗋𝗃.evaluate. But there's a lot of boilerplate and a lot of complexity associated with that. Another thing that you could do, and that was basically with either the built-in evaluators, we call them judges, or that was also with the custom prompt template judge, where you would write your own instruction set and then it could theoretically do whatever you wanted it to do. The only problem being with that is you're now in that sort of prompt engineering phase to make it better. So a lot of iteration to get the custom evaluator as good as you possibly can get it. It took, from people that we've talked to, it took weeks for them to get something that they're like, okay, this is pretty much like 80% good enough. We'll use this, for production monitoring, or we'll use this in our inner dev loop. But it was just a lot of effort. So we want to simplify that. And with this make judge API, you define a name of the judge. It's just a string, something, the unique identifier, whatever you want to call it. But the meat of it is this instructions string that you pass in. And you can see there are templates in here. And what's shown on screen right here is the basically the LLM-based judge. So you're doing direct, you write out your instruction set. You create these open and close double curly braces to identify either usage of inputs, outputs, and you can also add expectations. And then once you have that, we're going to interpolate from the data that's passed in to populate those. There's also a system prompt that goes into it that is immutable, that basically says, hey, you're operating as a judge, and this is, pay attention to what is in instructions and make sure that you can process this and answer the question that is provided here based on this data. And then the other thing that you define is the model. And this is the standard MLflow, syntax for basically dictating how to define an endpoint. And here I'm just referencing like, oh, we're using GPT-5 mini. Once we have that judge made, we can use MLflow.𝗕𝗂𝗋𝗃.evaluate, and we can pass in the data set that we passed. We can also pass in a list of dictionaries with inputs and outputs and expectations. You can also pass in a data frame, but the data set is where it really begins to shine, because it'll actually automatically, set you up to be able to reuse that over many evaluation runs. So you can kind of track your progress as you're making incremental improvements to your agent. And you can define the scores directly like you can built-in scores, and scores are going to be, they're already being expanded in functionality quite a bit right now. There's even more exciting things that are being coming in MLflow 3.6 with scores. But with what you see on screen here, we're defining that score, and it's just a list of these scores. And for each score that's defined in there, we're going to run that evaluation logic through the model that you have defined for the particular score. And the predicts function is basically the model that you're evaluating. In this instance, we just have inputs and expectations as an example, but we also support inputs, outputs as well. So you don't actually have to, run your model. You can just do it off of the data set directly. So that's the very basics of what we've done so far. We can dig a little bit more into data sets and like what they are. They are inherently dynamic. So they're fully mutable. We actually maintain a change record of when records are mutating. So they do overwrite and give you last state, but you can get the idea of like, when was this last updated? So you can track, like when you look at the actual records that are in that data set, they're going to have different commit times if you've been updating them. We use the actual input as the effectively index key on that data table. And so it'll replace in place if you have like the exact same input. And that's a cost savings measure so that you're not like adding records to something and you actually have the same input query that would be going to your actual agent. You don't want to run that like 10 times in a row. It's just wasting money. So that's why we did it that way. It's basically an upsert command. They are reusable and they're far simpler than doing stuff like trying to maintain dictionaries or arbitrary pandas data frames. You have no idea where they're stored or what the state of it is, what the version of it. This is just a centralized place for you to kind of keep track of them. And we can use tons of different sources. One key aspect of this, and this is kind of a PSA for everybody in the MLflow community, file store is going away. It can't support this particular API and a number of other APIs that we've built recently. We actually need the performance and the scalability of a SQL backend. So yeah, if you need to run it in local mode, you don't have a database that you can use, SQLite is your friend. It takes seconds to set one up. If you want examples, you can actually check in our unit tests in MLflow source code. We use it all the time. Anytime we need to do a SQL database test, we're using SQLite. And when we're doing testing ourselves, all of us we'll just spin up a new database to do some tests. I have a durable one that I've had for about 2 years now that just has loads of stuff in it. It's really fast. So after we create that data set with that SQL backend, we can merge directly, as I said before, that list of dictionaries. We can pass in inputs and outputs. We can also directly get traces, and you can apply not only just give me all the traces from a particular experiment, but you can also apply filters to it. So if you have tags associated with certain things, you're like, hey, I really want this to be something that we use for validation, apply a tag to that trace, and then use search traces to construct the record set that you're going to be putting into a data set. And we'll automatically parse all of that for you. The data sets, when they're actually loaded into memory, you can just do a .2df on it, and it'll create a pandas data frame directly for you. But natively, it is an object. Yeah, and as I mentioned before, data set with merge records, you can add records at any time. You can add it when you're creating the data set for the first time. You can also add it as you're going through iteratively testing and you start finding edge cases. You're like, oh, geez, when we asked this one question, it really lost its mind. Maybe we should ask 20 other questions that are kind of in this vein, just so that we make sure that we're not regressing things when we try to fix things. They can be associated with experiments. It's not a one-to-one mapping, which is kind of interesting. It's actually a one-to-many mapping, or actually it's a many-to-many mapping. Multiple experiments can have multiple data sets. Multiple data sets can be mapped to multiple experiments. There's no restrictions there. We maintain that lineage for you. Some of the APIs that you can use to interface with it is, of course, the get dataset API, the delete dataset API, which will actually do a cascade delete. So you don't have to worry about, oh, well, I wrote 1,000 records to this thing. I'm deleting the dataset. Do the rows go away? They'll get deleted if you delete the dataset. So you don't need to worry about cleaning that up. Search APIs, they're very similar to our other search APIs. And you can search on similar criteria that you can in other ones. Check out the docs for more details. And then we have two separate Fluent APIs associated with datasets, which are external to the creation. They're purely metadata. You can set tags on them, and those tags will be associated with that particular data set. So you can organize data sets with a certain project if you want, or a certain team. You can say like, hey, these are our 37 data sets that we use for stuff every day. And then of course we have the delete tags API. And then one thing, as I mentioned before, but to keep in mind when operating with these things, records are lazy loaded. So if you were to inspect the object that comes back from Git or search data sets, the memory impact of that is very small because it's just the metadata that's loaded when you fetch it. Once you try to interact with that object by doing something with the records themselves, that's when the lazy load will happen, and the records will be loaded only as needed. That prevents you from ooming out Python if you were to search on, say, 1,000 data sets that each have 100,000 rows. This makes it so that they only get loaded when you actually need them. And it's fully compatible with MLflow.GenAI.evaluate, as you saw in the examples before, which really streamlines the workflow for evaluation. Now, the slightly more exciting thing is the thing that we've been working on for the last 6 weeks or so. And that is agentic judges. So make judge, as I mentioned before, that's all sort of a prompt template that's using inputs, outputs as expectations. But there's another operation mode that's far more interesting. And that's if you were to put into your template a bracket, space, trace, space, close bracket, this judge no longer works as an LLM as a judge. It works as a agent as a judge. So what that actually really means is we'll be passing in the trace metadata, basically the trace info object in MLflow, which has stuff like what is the input to your call to an LLM or your call to an agent, what was the output, and what is the span ID, basically that root span ID for that trace. With the metadata that is available for that, we can then use features that have been released recently in MLflow, such as MLflow's MCP capabilities, where you can actually have a judge with that trace template actually make tool calls to MLflow. So it's going to be doing things like searching spans and querying different aspects of the things that make up that trace. And what this means is this now very simple instruction set of, whatever you tell it to do. I want you to evaluate if this, bracket trace is acceptable for this audience, or ask it for, correctness guarantees based on calculations that it might have made within its own tool calling. If we just pass in inputs, outputs, and expectations, there's no way to know what it actually was doing. It's not exposing really much to an evaluator. But when you give it the ability to call tools, it can evaluate each individual stage within that trace. It can see which particular span called a tool, or what its reasoning chain was at a certain point, or what intermediary stages were happening within the agent that were deciding what to do next or what not to do. Or if it needs to make a document retrieval request, what document did it retrieve and what were the contents of that document? Did it actually infer the correct information from that? So that aspect of the Make Judge API, even though it's slower, it's far more powerful than the standard LLM-based judges. And the other thing that comes out of this is, of course, a score, which is a standard interface. It's kind of our standardized way of doing evaluation, like moving forward in MLflow. It's a very flexible set of APIs. There's really cool things like you can register them. So you no longer have to keep a copy of an object in code and try to remember, like, what the heck version of this were we on? It was really good last week, but now it's kind of fallen apart. How do I get back to that previous state? Because you can now register it and name it, and you can search over the registered scores. You now have this persistent state of something that you can use for evaluation. And the third aspect of Make Judge, which is probably the most exciting, is the fact that you can align the actual instruction set. And how this works is we're leveraging dsPy's functionality for prompt optimization, and is actually using comparisons for evaluations that your initial evaluation, your Make Judge score provided, like whatever scores it came up with based on your instruction set and the data that it had. You can then, you yourself as a developer or subject matter experts can come in and leave their own feedback on these traces, which can then be incorporated into the data set as expectations. With that additional human level, feedback that's provided on how well it did, we have an align API that can then kick off a 𝗕𝗲𝗃 optimization run, which will rewrite that instruction set and allow you to create a new version of this score, which is pretty cool. It's shocking how well it works. We've tested it out a bunch with some very simple instruction sets, and seeing how it actually evolves over time and just how much better alignment it has to human feedback after you do this, call this API. So what we actually, creating an LLM judge, we already kind of talked about this, but this is just showing you again kind of how simple that API is. Provide the name while making the judge, the instructions with those. This is the LLM based one. So we have the outputs and the inputs templatized, and the model that we're going to be using for adjudication. Here using GPT-4, it's pretty good at doing this sort of template in inputs. You're going to want a much more powerful model, much more modern one for the agent-based one than GPT-4. And then using in evaluation, we just, use the predicts function, whatever your agent is or your chatbot is. The data is from a data set that includes all of those evaluations. I mean, the expectations that you have and whatever your inputs and outputs are, and then applying that as, to the scorers list. And we kind of already covered this with the template keys with inputs and outputs that kind of defines the LLM judge characteristics. And these can be invoked with these keyword arguments directly. You can just define inputs equals this, outputs equals this, expectations equals this, or just pass a trace or a data set directly that contains this information. Now, an agent-based judge, you can see we have the instructions are a little bit different. This is like a little bit more realistic looking. This would be like evaluate my RAG system. Hey, I'm retrieving some documents and I'm answering questions about it, and here's a trace that I want you to use to evaluate that. The thing that kicks in the agent mode for these is the fact that we just have that keyword trace, which tells the system like, hey, we're now going into tool calling. So in order to evaluate these considerations that are written in here, like, hey, did I get the right documents? Were documents that were retrieved, were they relevant to the question that was asked? And then you even ask like, hey, how well was the prompt that was submitted to this? Are there ideas of things that could be better? And the citations that might come back, are they correct? And then you're providing a rating, a numeric rating, 1 to 10 if you want. 1 to 5 usually works pretty well, and it'll come up with that as a response. What this will actually do on its output, though, and we'll see it here in a minute when I show you a little video, is it's going to provide that rating as the key value in the feedback, but it's also going to provide additional context with any of the ratings that it comes up with to kind of give you some insight into why it made the decision that it did based on all of the information that it had available to it. And that's the rationale that comes with it. And you can see here in my notes, the judge would actually go through, and the first tool that it would call within the MLflow MCP server is list spans to figure out like what was involved in this trace, what are all the steps. And then it'll start going and getting individual spans based on the retrieval ID and the metadata that comes back with list spans to figure out like, oh, I need to find the document retrieval step. Well, it's this particular span. And it's going to go and get that. It's going to, check what the actual prompt was that was instructed into that tool call. And then it'll find the citation to, check to see, did it make all the decisions that it should have made, or is there an error here, or did it have to retry, or did it just pull something completely nonsensical and then just start hallucinating and make some stuff up that seems kind of correct? So these sorts of judges will actually be able to determine stuff like that, and it can detect the fact that, oh, it pulled junk and it didn't know what to do with it, so it just made stuff up. So it would say like, oh, it hallucinated it in order to answer this the best of its abilities. And hopefully you'll be able to figure out what a root cause was from that. And then the comprehensive rating that comes out synthesized into a rationale. So as we mentioned, it's using the trace to call the MLflow tools via the MCP server, and it'll extract all of the information, evaluating it step by step. Now, alignment is where it gets really interesting. There's this whole concept of a score evolution, that instruction set changing and becoming more and more accurate and powerful over time. And you'll be able to see what this actually looks like with the sort of applying corrections to things. So here is a test that I did recently where we created a judge that was called Fantasy Loot Final. And it's going through and it's evaluating it. And as you see in the UI hovering over it, you can kind of see this is what the feedback is going to look like. If I pause here real quick, you can see we have the carry capacity judge that was created based on the question that was asked. It's ranking whether something's correct or incorrect, and it's providing a rationale. And it's going through and analyzing that full call stack as best as it can and inferring what it probably did and whether it answered things correctly. And it'll give you some tangible results instead of just a pass fail or a score from 1 to 5. That rationale is super key for you to understand, like, what should I be looking at here? What did it find that I might not have found as some sort of edge case condition? So it becomes very powerful when you start looking at that. But that next phase for alignment is going through and sort of correcting what the results were from an evaluation. As we go through here, slightly different. Oh, this is the same one actually. But if we don't agree with that, we can actually go in and we can say, well, I'm going to apply my own assessment to this and provide my own feedback. And I can create a new field in there that's, for this case, it's irrelevant. The judge answered a question. However, it didn't actually infer that the fact that it was evaluating whether the carry capacity for this mass of gold and silver would be something that a character could hold. Sorry, I'm an RPG geek. But the reason it's irrelevant is because that tool was never even called. The question didn't actually provide that. It didn't need to call that tool. So the judge might not be as optimal as possible. So what we can do is we can find within our evaluation runs each instance of something where this one particular judge wasn't doing something correctly. And then based on our feedback of applying this and saying like, no, you got this wrong. It didn't need to call the tool here. When we actually do an alignment run, it'll update that instruction set specifically for ignoring stuff like that or not rating something as incorrect or correct based on the fact that it omitted a step or it didn't need to do a step based on the input question. So there's lots of things you can do like that. And alignment is the way to kind of close this loop in a semi-automated fashion. You still have a human in the loop, and you definitely need a human in the loop. You want your subject matter experts and yourself to be involved in this process in order to make it better. But this gives you a way of doing this without having to go through the painful process of prompt optimization, of going through testing one thing, running eval, wasting loads and loads of money on doing this like iterative loop. And even though it does cost a lot of tokens to do all that stuff, it's the amount of time that you have to spend going through that process is where it really makes you suffer. So things that are next in MLflow. We're starting a rather large scale project called Insights. There's a prototype that's out there now. It's pretty cool. It allows you to plug in a coding assistant that allows you to basically do what the agentic judge that I was just talking about does, but it's sort of in a more interactive manner. So you're interfacing with Claude Code or Codex, and you're asking it to investigate the quality of all of the traces associated with your agent. And instead of you telling it like, hey, go evaluate these things, go figure out how I could potentially optimize my code. Like, where are bugs, basically? Or how can I build features that are going to make this even better? And it'll go and find stuff, and it'll basically create a series of insights, which you can think of as basically Jira tickets. They're like, hey, I found this thing. I have a hypothesis associated with it, with what should fix it, and then maybe use, from that information, directly tell your coding assistant to go and try and make a few of those changes, and then run through an eval loop again and make things better. So that's one thing that's coming. We're going to be releasing that in stages with increasing complexity over time after talking to community members and getting feedback from people. But based on our own internal testing, it seems like it's pretty worthwhile. Second thing, which will be coming sooner than that, is scheduled scores, the ability to run evaluations based on percentages of traces that are coming into an experiment, run those scores automatically. So that means you can set this up for production, and you can have production evaluation, do it either in the outer loop for prod, or set it up for your inner dev loop. You want to do a bug bash among a bunch of people, and you want to be able to get eval results right at the end of that, or have people see what eval is in real time while they're testing something out. This will allow you to do that. And trace support for the scores, particularly for the agentic ones. That's super critical. You want to be able to see what that thing was actually looking at within the traces that it's evaluating and what decisions it was making itself. So we're going to be looking at that, and a scorer UI in order to support a lot of this stuff, be able to see the results of a lot of the evaluations over time, as well as configuration of new scorers and just general monitoring of it. All right, that's my presentation.
Well, thank you, Ben. That was an illustrative example of a lot of insights into how you actually create judges and how you create data sets. Let's see what you actually have from the audience, a few questions that actually will come up. But before I go to the audience, we have about 15 minutes. I have some of my own questions. Who will be the person using this particular APIs? Who will be the persona? If you were to describe someone who is going to be using this particular API is to create data sets and to write evaluating functions, who would those be? Would they be data scientists? Would be ML engineer? Would they be AI engineers? Where would you actually place that person?
These will definitely be whoever's like just building these agents. Whatever the team is, it could be an individual, could be a number of different people. But when you're looking to actually leverage Gen AI for something other than, a cool demo, or like, hey, look what we can make this thing do. Like, hey, we need to make something that, or like, we're building a project that is going to solve a problem for our business, and we're funding this thing, and you're getting actual like really serious about building this. Those are the folks that are going to be hopefully getting some value out of this. We already have a number of users that we've been talking to over the past year and a half to 2 years, that a lot of this comes directly out of their needs. They're doing stuff at extreme scale. They're like, hey, we have 7 projects that we're trying to get into prod, and here's our pain points. This is where it sucks. And we're like, we can fix that for you, we hope.
And these are you described as the Gen AI application developers who are actually building agents to do stuff like that. Okay. Let's see. There's a question from Ravi Singh, hailing from San Diego. He actually had a comment, but I'm not sure if there's a question in there, but I'll just read that out to you. Ravi goes, I'm still struggling on LLM evaluation until I figure it out. I will not touch any other evaluation types except maybe TTS model or time series force carding models. So I'm not sure if there's a question in there or if there is just a reserved judgment in there. Uh, so I've pinged him, but he hasn't posted any question. But we also ask the following question, which is, can there be a multiple judges for an input somewhat like a jury, which each judge using a unique LLM models? So in other
Yeah.
words, can I have multiple judges that I can actually create, but each of them would be allocated or assigned or ascribed to using a different LLM model. How would you actually do that using the API? Because from what I gather, looking at the code, the API just creates one instance of a judge. How would that work?
So you can have multiple scorers defined. So each scorer is going to be its own judge effectively.
Uh,
So when you use MLflow.GenAI.evaluate, tests that we've done, we've been like, hey, let's do all the built-ins, which I think we have 5 or 6 of them now, the one that are relevant to whatever the agent that we're doing. And then we'll add in like 20 custom make judges.
mm,
And so when you use that evaluate API, that one, like each row of that data set that is effectively a trace, it's going and firing off in parallel. It's like through an async framework, uh, evaluations on each trace,
mhm,
and you'll get all of them back at once. And in that video that I showed earlier, if anybody saw it, was kind of fast, but in the MLflow UI, uh, even with that demo, there was, for I think that one I had six
mhm,
judges that were running. So
mhm.
for each input output, we have 6 results, and there's not
But
really there's an upper limit. I think
right.
it's a very large number, but I can't remember correctly. It might be like 1,000 is the limit, and then that. But if you're in that realm, you're doing very, very serious things.
But does the application programmer who wants to use multiple judges, do they actually have the control of saying which judge should be assigned, what LLM should be assigned to which judge? So let's say
Yeah.
I have six LLMs. So how does it determine? Is there like a pool? Let's say I want to use Sonnet, I want to use GPT-5, I want to use Llama, I want to use something else. Where do they define that?
Yeah, when you create your scorer, you have that model field. So
Okay,
you define like OpenAI
okay,
/
okay, okay.
GPT-4o, and that's actually in that example that I showed, that was using 4 different LLMs, because each of the things that were being adjudicated were different
Hmm.
levels of
Hmm.
complexity.
Hmm.
Like something that like a built-in correctness score does not require an expensive, powerful model. It can use something very old, very cheap, and it's usually pretty good. Of just being able to say like, did it answer the like, was it a relevant question? I mean, relevant answer to the question that was asked. But when you start digging into, you know, very esoteric, complex, judges that are evaluating something that might involve some mathematical calculations, or
Hmm. Hmm.
uh, the demo that I almost showed for this was actually something about astrophysics, where it was determining stuff about like stellar bodies
Hmm.
and what are the gravitational effects of like an asteroid coming in close to a planet.
Hmm.
Now, if you were to ask uh, like GPT-5 these questions, it'll sound reasonably correct,
Hmm.
but the moment you do the math yourself, you're like, well, this is way off. So you
Hmm.
create all these tools and stuff,
Hmm.
and the
Hmm.
tools do all those deterministic calculations so that it gives you what you're looking for.
Hmm.
But you can't evaluate the structure of a question like that involves that complexity with a cheap
Hmm.
model. So for something like that, you would use the most powerful. For that example, I actually used GPT-5 to evaluate Opus. So Opus answered the questions, and then GPT-5 was evaluating. And so you have like the 2 titans of state of the art, one answering, one adjudicating. But that's just that one judge using that super expensive LLM.
Now, talking about evaluating functions, um, how can you? I mean, first the question was can you actually wipe code as evaluating functions instead of you writing what? Can you actually ask uh, cursor or cloud code? to write these functions?
Yes.
Yes, you can. Okay.
Yeah. So I currently have because I'm working on a couple of these things that are on screen right now, or that were on screen on that last slide. In order to do, like, anybody that's written sufficiently complex code knows that
Hmm.
unit tests are great. Unit tests are
Hmm.
awesome.
Hmm.
Uh, Integration tests are even better, but
Hmm.
a full end-to-end, true pipeline test is the only way to go if you're making big blast radius changes to APIs. Or like,
Hmm.
hey, I really need to change, like, fundamentally how this thing works. It's scary to make that change unless you can really test it out end to end and see, like, okay, I'm changing this, like, base abstraction layer here. How bad is that going to make stuff?
Hmm.
So I needed to create a full stack effectively, including a UI that allows me to interface with a very complex agent that has 500 tools available to it. Then each of those tools are doing loads and loads of crazy stuff. So that astrophysics demo, actually, that's what I use for my own testing when I'm making changes to MLflow for, like, some of these score things. That whole thing, I don't have time to write that.
Hmm.
Claude wrote it,
Hmm.
and Claude validated it, and then I
Hmm.
use it and tell Claude how to make it better.
Hmm.
So
Hmm.
we're dog fooding a lot of this stuff with
Okay.
our
Okay.
own testing.
Okay.
Um, but that code, uh, it's upwards of 50,000 lines of code that it's
Hmm.
generated for this thing.
Hmm.
So yeah, entirely possible for it to create loads and loads of stuff if you give it enough context and give it enough
Yes.
examples.
Yes. Yes.
I
Yes.
wrote
Yes.
like
Yes.
3
Yes.
functions. I'm
Yes.
like, here's
Yes.
how I want my tools to be defined. You
Hmm.
understand how MCP works,
Hmm.
so register
Hmm.
these. And
Hmm.
yeah, it just went to town. I mean, it took me 2 weeks,
Hmm.
spread out over a month and a half to construct the whole thing. But yeah, I just have a terminal window that's dedicated specifically for that, for Claude to kind of use. So it totally plausible.
Yeah, I mean, you hit it on the nail. Context is very much important. So you're
Yeah.
providing the right context, then the cloud code will be able to generate the function. And obviously, you go through the iterative cycle. So your autonomous slider is you evaluating
Yep.
and verifying. We have a question from 𝗕𝗂𝗶𝗵 from LinkedIn. He said, "What about parallel computing within the MLflow? Can you explain it?" By parallel computing, I assume he actually means tasks executing in parallel, or is there parallel computing meaning judges evaluating those in parallel? I'm not sure, but sort of a general question.
Yeah. I mean, there's a number of places that we support that. Um, not
I think within the context of evaluating the judges, would parallel computing actually make sense? So if you had, let's say, as Ravi pointed out, that can I ascribe 6 judges, and each judge, would the judge now be running those in parallel, or would that
Yeah.
be something? Okay, so
Yeah.
this
Yeah.
would be one instance where you are actually judging your answer to the question. Those would be actually forked off in parallel.
Yeah, definitely. Otherwise, if you add 20 scorers to an
Yes,
eval
yes,
run,
yes, yes,
think about that
yes.
sequentially. It'll be like hours before it finishes. So we'll run, I think by default, I believe it's 10 in parallel.
Yeah. But I'm assuming by parallel computing, it actually doesn't mean that there's going to be shift up to the cluster, but they may be running in parallel threads
Right, right.
within. Yes, yes,
Yeah, yeah,
yes.
it's a
Okay,
thread pool.
okay.
Yeah.
Yeah, it's a thread pool. Brilliant, brilliant. Um, I have my own question about creating data sets. So when you actually have in that API, when you say go ahead and create a data set, and you give it a particular name to it, how does the API understand what type of data set is it you actually want to create, or how does it actually comprehend how and what to create? What would be the form and format of a data set look like?
So it's highly opinionated. It's not a
Mm,
free
mm,
form like Spark data frame or anything like that.
mhm, mhm,
It is a data structure that is geared for evaluation. So
mhm,
if you look at the table in the SQL backend,
mhm,
it's got an index, like a unique ID,
mhm,
um, and then it has a reference link ID that allows for associations. So like, oh, this is associated with this experiment, and maybe in the future we'll be like, oh, this is pre-associated with scores or something. But so it has a whole bunch of metadata associated with it, like who created it, what date time did they create it, when was the last time it updated, and then it has within another table, which links to that ID, which is the actual rows of the data set. And that basically just has the metadata keys for joining, and it's got input column, output column, and expectations. And the expectations can either be, code-based feedback, and or it can be human derived. So it's fairly limited in what it does, but it gives you the core things that you need in order to run eval with these data sets in a structured way, so that it's not, if we made it fully flexible, it would be impossible to actually know how to use it internally within MLflow. So providing that structure makes it so that it works with the other APIs.
Finally, I was delighted to hear, even though I've been away from MLflow for a long time, since 2.0, that you did mention that file store is going to be deprecated.
Yeah, it's got to go. It's got to go.
So by the default, when people create an experiment, by default, it's going to be SQLite.
Yes, and we'll be making that change over the next couple of releases. Also updating all of the documentation, the quick starts, to just basically set that up and make it so that it's as simple as possible, because it really is simple. It seems scary if you're just thinking about it, like, well, before I could just just run MLflow. And now it'll be, the addition of a couple of lines of code, but it shouldn't be that bad.
But they would still have to declare to say set the experiment tracker to be SQLite if you're running locally on your machine, or it just assumes that it's going to be local, and by default it will create in the MLflow DB as your SQLite, or is that something that you have to specify? We don't know yet.
Still TBD.
Okay.
Design,
Brilliant,
I think, is coming next week.
Yeah. I think we're almost close to time. I'm trying to find out. Yeah, there's another question. What sort of integration do we actually have with, say, data catalogs? For example, Iceberg, Unity catalog with Polaris. I'm assuming everything you talked about today was the MLflow open source, correct?
Yes. So
Okay.
that's with our own tracking server.
Okay. So in terms of, is there any integration plan with any of the open source catalogs?
We have integration with Unity catalog open source for the model registry.
Right.
And that kind of mirrors how it works on Databricks. Not quite as fully featured, but it functions. And we have tests that run with every PR that validates that it's working. We haven't actually heard too many feature requests from anybody in the community. The way to get in touch with us is GitHub issues. And the way to get a feature request prioritized is by getting a bunch of buddies to give a thumbs up to it. So we haven't really heard anybody really requesting anything other than Unity catalog open source. But if people have things that they would like to see, file an issue. We check that stuff. If we see something where there's a lot of traction on it, we might think about prioritizing.
Okay. So whoever asked the question, I think if we hear a lot of demand about giving support for other open source catalogs, then it will appear. And if you think that you want to contribute, that would be one way to do that.
Yes.
So with that, I think we are right on the hour mark. Thanks a lot, Ben, for your elucidation on all the aspects of today's meetup, evaluating data sets, creating judges, and what's coming up in the next couple of releases. And hope to host you again sometime in the next month or so. And thanks, Carly, for all your help. And thanks you all for joining, and hope to see you again. And don't forget, tomorrow the AMA at 1 p.m. Central Time. Ben, are you going to be joining?
It's not on my calendar. I don't
Okay.
know.
Well, we should
We'll see.
put you in the calendar then. All right. Thanks a lot. Good evening and